Okay, so now we are at the new thing, which is dividing functions. And the only thing new is that when you divide two functions, you create a rational function and there is a denominator. And so with the domain, remember, denominators have special problems. You can't have them equal 0. So the domain of the quotient, you find the domain of f, you find the domain of g. That's what you usually do. But then you also have to remember that the denominator, whatever's in the bottom, which is g of x, the way we've written this, cannot equal 0. Okay, so we just have an extra thing to find. Alright, so to find f divided by g and the domain, given these two functions, f of g of x is equal to x squared plus 2x over x squared. Now, a little bit of algebra here. I like this example here because I'm going to know a common error and you're probably wanting to do it. That is wrong. You cannot do that because this is a grouping symbol. So these are in parentheses, and PEMDAS, it's always about PEMDAS, says you have to do the parentheses before you can divide. You'd have to add these before you could ever divide. Okay, now you could distribute just like you do with multiplication. You can distribute division into a parentheses if you just remember that this belongs to both of them. So if you wanted to simplify this, this could be x squared divided by x squared plus 2x divided by x squared. Now that is legal, but only dividing this x squared by that x squared is not legal. That then simplifies to 1 because anything divided by itself is 1, plus here's a little algebra. This is x to the 1, this is x to the 2. So x divided by x squared, you subtract the exponents and there's an x left on the bottom. So that's what you get if you simplify that. And now we find the domain. So the domain of this function is all real numbers. The domain of this function is all real numbers. Remember, domain is not solving. I'm saying all the numbers in the universe could be plugged in this function and you would get a y coordinate ordered coordinate with it. Same thing here. But then remember, with division you have a second step where you have to set this g of x, which is in the bottom here, not equal to 0. And so that means x cannot equal 0. So that changes your domain. So the domain of f divided by g is not all real numbers anymore. It's everything but 0, because putting 0 into this function would give you 0 in the bottom of a fraction. Second one, f divided by g. Look at this function. F is already a rational function and g is here. So f of x divided by g of x would be x plus 2 over x minus 3 over x plus 4. Now I try to slide in a little bit of algebra while we're doing this, so I just reviewed you can't cancel when you have this fraction bar. You have to distribute to both of them. And now this is what we call a complex fraction. So a complex fraction is a fraction that has a fraction in it, and you need to know how to get rid of a complex fraction. Okay, and it's really easy to get rid of it. So let me just take a time out. If I had 1/2 divided by 3/4, the way that you get rid of a complex fraction is you remember that division is the same as multiplying by the reciprocal. Just like subtraction is the same as adding the opposite, division is the same as the opposite of division is multiplication by the reciprocal. So I would just rewrite this as 1/2 times the reciprocal of 3/4 is 4/3. Okay, so some of you may have learned it. Your teacher may have said copy, change, flip. Okay, you could do it that way, and then you could cross cancel. 2 goes into 2 once, 2 goes into 4 twice, so that ends up being 2/3. No more complex fraction. So you have to know how to get rid of a complex fraction by understanding division is the same as multiplying by the reciprocal. So now we have this number here. It's a number. It's an expression divided by this number. And how would you make this number a fraction? Well, you can put anything over 1 and make it a fraction. So see those two things? And now we're going to get rid of this complex fraction by copy, change, division to multiplication, flip. Or division is the same as taking this number up here and multiplying by the reciprocal of the denominator. So what happens there is that's x plus 2 over parentheses x minus 3 times x plus 4. And there's no need to multiply that out. You'll never, ever, 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 ever need to multiply the denominator out if it's something in factored form. If we multiply that out, we would get a quadratic. And we've already learned how much easier multiplication is, so we'll just leave that factored. Okay, now we need to find the domain. So remember, the domain is complicated with division. You find the domain of this, and you should be able to kind of see quickly that that is x cannot equal 3. And then this one is all real numbers. But then you have a third problem. You have to set this bottom function, which is g of x, not equal to 0. So x cannot equal negative 4 if I set that not equal to 0. Okay, so then we're going to draw a number line and just keep doing it the long way till you start to remember. If you have two places where it can't be a number, it's going to end up looking like there are 3 places where the numbers exist. So this domain would be negative infinity to negative 4, union negative 4 to 3, union 3 to infinity. Okay, so that's division of functions. All right, now we have something really completely different. It's called function composition. The reason we're doing it now, it's 2 functions that we're going to work with, but it's actually a new operation. So you've learned addition, you've learned subtraction, you've learned multiplication, and you've learned division all your life. Well, now we have this new symbol. It's an open circle. Okay, pay attention to the open circle, and that's function composition. So if you see f, a little open circle, g of an input x, what it means is that you need to stick this g of x function into the f function. That's function composition. And the order matters. So if you had g open circle f of x, that would mean that you're going to put the f function into the g function. So if you like diagrams, here's what's happening. You start out with your input. You always start with your input x. And for this, what do we do first? Well, we put that input into the G machine. Okay, and then if you put an input into a G machine, an output comes out. So you put the x in, and then you get an output. Okay, the G machine worked on the input and turned it in. It's like going into a wash machine. There we go. Now that output becomes an input, and you put that input, which was the same as the output, into the F machine. Okay, and so you get your final answer. All right, so let's do it with numbers first. So this says F open circle G parentheses 5. So what that means is F of G of 5. So that means we're going to take this input and put it into the G machine first. Okay, so G of 5, there's your G. That's 5 minus 3, so that's 2. So when you put in 5 into the G machine, out came 2. Now we're going to take that 2, and that 2 is going to become an input, and we're now going to put that 2 into the F machine. So F of 2, f of x is x squared, so f of 2 is 2 squared, and that's 4. That's function composition with numbers. All right, pause the video, try g of f of 7. Okay, g of f of 7 means 7 is my input, and I'm going to put it into the f function, which is x squared. So f of 7 equals 7 squared is 49. And then that output, 49, becomes the input, and I put it into g. So g of 49 is equal to 49 minus 3, which is 46. Did you get that? Next, find the functions f of g and g of x and their domains. All right, so that's one thing. The second thing is to find the domain of a composed function. This is function composition. You find the inner functions domain and the final functions domain and find the intersection. So this is where it gets a little harder. We don't have specific inputs now. So it's going to test your knowledge of function composition and function notation. All right, so what does this mean? F open circle g of x means f of g of x. Okay, so this is a lot different. So we don't have anything to put into the g, so we just skip right to this. We need to put the entire g function into the f function. Okay, so you have to understand that this x really isn't x. It's this placeholder for what you put in there. This means f of whatever I put in is 4 times whatever I put in minus 2. So this x is going to disappear, and some people just don't want to get rid of it. They just want to hold on to it. This x is a spot right here and here that's going to go away. So f of g of x means I'm going to put the entire g of x function, which is 3 minus 2x squared, in where the x was. Okay, this 4 times x, the 4 is gone. The x is gone. Okay, because you're going to put something in its place. Well, what are you putting in? What's your input? The expression 3 minus 2x squared. So that would be 12 minus 8x squared minus 2 if we distribute, and then that would be 10 minus 8x squared. Okay, that domain is a little trivial. I'm going to come back to the domain. Let's get on a roll here. Let's do g of f of x. What does that mean? G open circle f of x means g of f of x. Because I don't have a specific number, I'm just going to put the entire f function into the g function. Okay, so g of f is 4x minus 2. Okay, so 4x minus 2 is my f function. It's got to go into the g function. G function is g of whatever I put in. This stands for input, is equal to 3 minus 2 times that input quantity squared. So this x is going to go away, and this is going to go in its place. Here's g. 3 minus 2, x stands for input. Okay, so that's gone. And I'm going to put 4x minus 2 quantity squared in its place. Now we practice a little bit of algebra. So here, are you tempted to do 3 minus 2? A lot of people do that. Remember, PEMDAS never goes away. So you cannot subtract before you multiply. Are you going to multiply 2 in or negative 2 in? I hope not. That also fails PEMDAS. You have to take care of the exponents before you multiply. So if you look at this problem, you have to take your time and you have to say, oh, I have to do the exponents first. And so that gives us a chance to remember how to do 4x minus 2 quantity squared. Well, you can do it the long way. 3 minus 2 times 4x minus 2 times 4x minus 2, and write that twice, but I like to do something called square double square. So take that 4x and square it. That's 16x squared. Multiply the 4x and the negative 2, you get negative 8x, and there's always going to be 2 of them, so you double that. So that would be minus 16x. Then you take that negative 2 and you square it. It's a whole lot quicker if you learn how to square double square. If you don't like my method right yet, you could FOIL it out. 4x times 4x is 16x squared. 4x times negative 2 is negative 8x. Then down here, negative 2 times 4x is another negative 8x. That's where that came from. Negative 16x. And then negative 2 times negative 2 is 4. So square, double, square is a nice little trick for taking a binomial and squaring it quickly. All right, now we have to distribute the negative 2. So that's 3 minus 32x squared. And then got to watch your signs. Negative times a negative is a positive 32x. And then a negative 2 times a positive 4 is a negative 8. So we're following the order of operations. And then lastly, we'll add like terms, and I'll put it in descending order. Negative 32x squared plus 32x, and then 3 minus 8 is negative 5. So that's g of f of x. And see, notice how wildly different they are. F of g does not equal g of f. Okay, the order matters. All right, let's talk about domain. So to find the domain, you find the domain of the inner function. So here, g of x is my inner function, and the domain of this inner function is all real numbers. Then you don't need to worry about finding the domain of f, you just look at the final answer. The domain of the final answer is all real numbers. So this domain of f of g is all real numbers. Okay, if we look at this one, it's the inner and the final. So if you look at f of x, that's 4x minus 2, that's all real numbers. If you look at the final answer, that's all real numbers. So both of these have domains that are all real numbers. All right, now we've got something different going on in C. We are going to use this f function and this h function. So f of h of x means we're going to put the h function, which is 1 over x minus 2, into the f function, which is 4 times the input minus 2. So this is going to go in there in place of the x. If you're hanging on to that x, not quite understanding, that x is the input we substitute in. I can make 4 over 1, so that would be 4 over x minus 2 minus 2, and we will leave it at that. We could subtract those with a common denominator. I don't want you to do that at this stage. All right, now it's time to find the domain. So we have to find the domain of the inner one, and the inner one was h of x, and x minus 2 is in the bottom, so x can't be 2. And we look at the final one, and still x can't be 2. So our domain of this one, domain of f of h, is everything but 2. Negative infinity to 2, union 2 to infinity. This one, h of g of x, means we're going to put the g of x function into the h function. So that's h of 3 minus 2x squared. That's my g of x function. My h function is 1 over, no more x, 1 over input minus 2. Well, my input is the g function. Okay, and so that's 1 over 3 minus 2 is 1 minus 2x squared. Okay, so to find this domain, we have to look at the inside, the function of the inside, which is all real numbers. And then the final answer, and remember that cannot equal 0, so this we had to do a little work. 1 minus 2x squared cannot equal 0. So try to be methodical about it. You may not know how to solve that right now, but just say, well, I know the denominator cannot equal 0. Well, then use your algebra. So we can subtract 1 from both sides. That gives you negative 2x squared equals negative 1. We're trying to solve for x. Going to divide by negative 2. X squared equals 1/2. Okay, get rid of the square. Here's a little bit of algebra review. When you take the square root, you always have to account for both the positive and negative answer. So when you take the square root, get rid of a square, and you take the square root, it wasn't there before, then it's plus or minus. So that domain is going to be, can't be those two things, is going to be negative infinity to negative square root of 1/2, parentheses union, parentheses negative square root of 1/2 to 1/2 square root of 1/2 union square root of 1/2 to infinity. So what I did is I just hopped over negative square root of 1/2, but then I remembered that these are solutions, and then I hopped over the square root of 1/2. Alright, the example 3 is just a way of practicing this quickly, working from one function to the next function. So here's a graph. This is g of x, and this is f of x right here. And we want to find g of f of 0. So 0 is my input, and according to the f function, the output is 0. So then that's g of 0. But then g of 0 becomes the input, and we want to find the output according to the g function, and that would be 3. So g of f of 0 is 3. Here, f open circle g of 0, that means f of g of 0. So we're just practicing on our notation. And this means that you're going to look at the input 0 and then put it into the g function first, which is 3. So g of 0 is 3, but that output is now going to become an input. So f of 3, here's 3, and you get output 0. And then you can even use the same function. G open circle g of negative 2 means g of negative 2. So find g of negative 2 first. When x is negative 2, g is 1. That output is now going to become an input. Now g of 1 is 4. Okay, now the last part of this lesson is the toughest for students, but I have a way that you can get it right every time. So stick with me for 3 examples, and then I think you'll have it. You can go practice in the lab manual. Alright, so it says if capital F of x is the function composition f of g. We want to go backwards, and we want to find the f of x and the g of x that makes that happen. So you're given the final answer, and you need to find the 2 baby functions that make that. Well, the first thing you have to understand is the order. So if it says f open circle g, remember it's the g of x function that's going to go inside the f function. Okay, so I personally like to find the g of x function first, the inside function first. And so here's my method. You just take a look at this, find the input x, and you have to find one thing that's happened to x. Well, one thing that's happened to x is it's been taken the square root of. So let's just let g of x equal the square root of x. Then you see how I circled it? I did that on purpose because whatever I circled in now f of x is going to become x. And those are my 2 functions. And you can check it out. If I put g of x, square root of x, into f of x, would I get the square root of x plus 1? Okay. I told you 3 examples before you panic. Alright, here's the second one. F of x equals 1 over x plus 3. Now this is the final answer. I am told to find f of g and g such that if I put g into f, I'll get that. But here's my trick. I like to start with the inner one first and the last one second. So you find the input x and look at one thing that's being done to it. You can't do 1 divided by x. That violates the order of operations. So x plus 3 would be a good thing to circle. So g of x is x plus 3. So then what would f of x be? Well, f of x would be 1 over x. And then check your work. If I were to put g of x, which is x plus 3, in place of that function where the input is, you would get 1 over x plus 3. So that's that. Now, the more operations that are in the function, the more choices you have. There are more than one answer sometimes. So, for example, this one, if I want to find a g of x and an f of x that work for this one, if you use my method, then you're going to go find x, and you're going to look at the one thing that's being done to x. The first thing is that x minus 1. So you could let g of x equal x minus 1. And then f of x would be 3. That parentheses is x cubed minus 2. Remember, wherever that that circle is, that's what you're going to put x in for it. And you can check it. If I put x minus 1 into that function, I will get what I started with. But you might try and pause the video, see if you can get it 2 more ways. There's actually 2 different ways that I see that you could write this function. So I could let g of x equal x minus 1 cubed. And if I did that, can you figure out what f of x would be? That would be 3x minus 2. That works. Can you think of another one? How about g of x equals 3 times x minus 1 cubed? And then what would f of x be? X minus 2. So the one thing you can't do is just let g of x be x. That's too trivial. You have to have something happen to x there. So in the lab manual, you have problems like this to try in the function composition section. So try those, and I think we'll end it there. So good luck with function composition.